Hey guys, in this video, I'm going to be teaching you guys how to factor or factoring using the greatest common factor. Um, so, greatest common factor is also known as GCF. So, GCF also stands for greatest common factor. And then, first of all, what is factoring in general? So factoring is the act of breaking stuff apart. So when two things are multiplied together, you can also take them apart. And you can do that. It's kind of like doing the distributive property, but backwards. So if you think about it like distributive property, you have a term on the outside, and then you're multiplying by everything on the inside. Um, that would be multiplying it in or distributive property. Factoring, it's like doing the distributive property, but in reverse. So let me illustrate that for you guys here. For example, let's say we want to multiply, uh, let's say we want to multiply 3x times 4 minus y, right? So normally you would multiply this with the distributive property, um, and that would give you the 12x minus 3xy. So that's a 4, by the way. Sorry, my ugly writing is bad with this stylus. But anyways, the idea is that if you do this way, it is called the distributive property. So distributive property. Um, and if you do it the other way, like let's say you want to go from here to there, this is called factoring. Specifically, you're factoring out the greatest common factor, or GCF. So I'm going to give you the steps. Again, this is all stuff that you should have in your notes. If you guys are taking notes along with this presentation, go ahead and put this in your notebook. That way you guys can get the notes in there and get credit for that as well. And let's go through the steps. So if you need to pause the video at any moment because you need to write down the steps because I went over them too quickly, you could always do that. There's only 3 steps. So step number 1, find the biggest number that you can divide all the coefficients by, and then the coefficients, for example, are the numbers that are in front of the variable. Like in the term 2x, the coefficient would be the number in front of the variable, which is a 2. So that would be the coefficient. So you take the biggest number that you can divide by all the coefficients, or that you can divide all the coefficients by, excuse me. And if the first term is a negative, you should take out a negative for that. Second step is find the variables that all the terms have in common. And then the third step is the GCF is the term from the previous steps, basically those two. And you take out the GCF from the parentheses and then place additional terms inside the parentheses that will make the original expression true. So, so find the variables that all the terms have in common. A lot of the times I didn't write this in my notes when I did it, but this is usually the lowest power that is shared between every single one of the terms. So it is the lowest power that is shared between every single one of the terms. If it is confusing to you right now and you already wrote down the steps, I will do some examples for you so you can understand what it is that we are doing. So essentially, but the thing is up here though, it's like you're doing distributive property, but you're doing it in reverse. You're doing it backwards. So you get something like this and you're trying to break it apart into what times what gives you that. So that's essentially what we're doing. But the key is that you want to be taking out the most amount possible. So hence the greatest common factor. Okay, let's jump into an example here. Again, if you had a pause to finish taking the notes, go ahead and do that. So example number 1 is this example, which is 6x squared minus 8x. So I'm going to go ahead and color code this. Notice that I have coefficients here as the 6 and the negative 8. I also have variables, x squared and x. So the first thing I need to do is say, okay, what number can I take out of the 6 and the 8? Or better yet, what number can I divide the 6 and the 8 by that is the biggest number possible? So as you can tell, the only number that goes into it and the biggest possible for that would be the number 2. So 2 is a number that, because I can divide the 6 by the 2 and I can divide the 8 by the 2 as well. So 2 is a number that I can take outside. This is the number that they both have in common in terms of the 6 and the negative 8. Now I have to do the same thing, but I have to do it for the variables. So what variable can I take out of both of them? This one has two x's and this one has one x, right? So I can take out one x from both of them at the very least. So I'm going to go ahead and take an x out. And like I mentioned earlier in the notes, like in the steps, it is always the one with the lowest power. If you want to think about it that way, like the lowest power between the two and this is the one. So I take out that power there because they both have that in common. Or another way to think about it is, what is the most you can take out of both of them? Just the most I can take is an x from both. Now that you have that, okay, so now you have to work backwards. That means that you know that it's something minus something, right? So we're going to have a minus in the middle. The question is, what can I multiply the 2 by to get a 6? So you got a 2 times what gives you 6? Well, the answer for that will be 3. So there should be a 3 there. And then I want 2 x's to get my original term. I only have 1, so I'm missing 1 more. Now, if you notice, if I do the distributive property here, 2x times 3x will give me 6x squared. So I get the original term. So that's perfect. We're almost done. I just got to do it again. So let's start with the coefficient. 2 times what will give me negative 8. I already put the negative in the middle because there was a negative in the middle. But as you can see, the number for that should be a 4, right? So 2 times 4 would give me 8. I already have an x on the outside, and I need an x for the term. Do I need to add another x here? The answer is no, I don't, because I already have an x on the outside. So my final answer is this. The greatest common factor, or the factored out expression for this, is 2x times 3x minus 4. So we're doing distributive property, but in reverse. If you want to check your answer, you can feel free to check your answer. If you take this times that and this times that, it should give you the original answer or the original problem. Okay, we'll do a couple more examples and then I'll call it a day and I'll let you guys work on your assignment. So example number 2, we have to factor the expression 9y squared x plus 3x. So let's start with the coefficient. So I have a coefficient of 9 and a coefficient of positive 3. Now start with that. Is there anything that I can take out of both of them? Meaning, is there any number that I can divide them both by that is the biggest possible? I can divide them both by 3. So I can take a 3 on the outside, and I'm going to put a parentheses in a minute, but now I have to look at the coefficients. Are there any coefficients that they both have in common? Here I have a y squared. Here I don't have any y, so I can't take any y's out. But I can't take an x out, right? Because they both have an x in both of the terms. So therefore, I can take 3 and I can also take out an x, which makes it 3x that I can take out. Okay, now that I know what I can take out of this, I am going to be having to do the same thing that I did in the last problem and figure out, okay, what am I missing here? What terms am I missing that'll make me get the original problem? So let's start with the 3. 3 times what will give me 9? And the answer for that will be 3. Now I want y squared x, but I have an x, but I'm missing a y squared in this term. So I'm going to incorporate the y squared right there in the first term because I didn't have it outside already. There's a plus in the middle, so I'm going to put a plus sign. And then finally, what can I multiply the 3x by to get 3x? Well, that should be obvious, right? 3 times 1 will give you 3. 3 times 1 is 3. And then x times 1 is x because I already had an x on the outside. So I'm pretty much done here. So my final answer for example number 2 is this. The greatest common factor between these two terms, or this binomial, is 3x. And then that is 3x multiplied with 3y squared plus 1. Okay? Hopefully it's not as hard. We're going to be doing 2 more examples and then we'll call it a day. And then hopefully you'll have enough to do your assignment. Okay, so example number 3. This one's getting a little longer now. Some of them will be long. Don't panic. You still do it the same way. So let's start with the coefficients. So we have the coefficients of 18, negative 30, and then 42. Now we got to think hard about this because this is the part where people will start getting wrong answers. Because what numbers can I divide 18, 30, and 42 by? I can divide it by 2, right? I can also divide it by 3. And I can also divide it by 6. So 2 works, 3 works, and 6 works. Which one is the greatest? as you can see, the greatest between all three is the 6. So I'm not going to be taking out a 2, and I'm not going to be taking out a 3. I'm going to be taking out the greatest from all three that I can take out, which is the 6. So I will take a 6 on the outside because they're all divisible by 6. So I just got to work my way through the problem and then try to see if I can take other things out. So now let's see if I have A's in all three terms. So as you can see, I do have A's in all three terms. I have a to the power of 3, a to the power of 2, a to the power of 2. The most that I can take out from all three is a to the power of 2 because they all have at least a squared in common. Same procedure. So let's move on to the next one. B to the power of 2, B, and then B. They all have a B in common at the very least. So I can take a B out, right? They don't all have B squared, but they all have a B. So we can take a B out at the very least. And then finally, we have to look at the C. So we have a C here and a C squared there and a C there. So as you can see, they all have C in common. So I can take a C and a C out, and the most that I can take out is just one C because all three of them have a C in common. But that is the most that we can take out, right? So we established that we can take 6a squared bc out. Now we just have to figure out, okay, what goes on the inside. The rest is the same. So 6 times what will give me 18? That will be 3. A squared times what will give me a to the power of 3? That will be a. B times what will give me b squared? Well, I'm missing a b for that one, right? C times what will give me C? Well, that's a 1. I already have a C on the outside, so I don't even have to worry about writing the 1 because 3 times 1 is just 3 anyways. So I'm done. Now I just skip to the next part. So I have a minus in the middle. Now we got to do it again. 6 times what will give me 30? That will be a 5. A squared times what will give me a squared? Well, I'm set, right? I already have a squared here and there, so I don't have to worry about that, so skip. B times what will give me B? Well, that's a 1 as well, so I don't have to worry about that because I already have a B. And then C times what will give me C squared? That one I have not accounted for, so I need to add a C here because we're missing a C for us to be able to get this original term. Okay, last term is we have a plus in the middle, and then we have to multiply this to get 42. So 6 times what is 42? That will be a 7, right? 6 times 7 is 42. A squared, I already have a squared on the outside. I need a squared, so I'm good on that. I have a b on the outside. I need a b, so I'm good on that. I have a c on the outside. I already counted for that c, so I'm good. So all that means is that you are done with the problem. So the final answer will be this, that the greatest common factor, the factored expression of the original term, is 6a squared bc multiplied by 3ab minus 5c plus 7. Okay, like I said, the problem is longer, but it's the exact same procedure. All right, so down to the last one for this assignment. So let's try to figure out the same thing. So let's try to see if we want to factor this expression, what can we take out of these three terms? Think about a number that you can take out of those three terms. Yes, you can take out a 2 from all of them. Yes, you can take out a 4 from all of them. However, which one is greatest? Because remember, we're looking for the GCF. So the greatest that we can take out is actually the 4. So the thing about this that I mentioned in the notes is, or actually, I don't think I mentioned it in the notes up there on the steps, but I'm going to put a little note here so that you can remember. If the first term is negative, then you take out a negative. So what that means is, in this case, since we have a negative 4 in the very, very front of the whole entire thing, yes, I can take a 4 out, but instead of taking a 4 out, I'm going to be taking a negative 4 out of the whole entire thing. And the only reason for that is because the first number is a negative, so therefore I'm going to take a negative outside. Simple as that. Okay, now that we have that, okay, let's move on to the next ones. The rest is the same. So we have x to the power of 5, we have x to the power of 4, we have x to the power of 4. I have x's on all three terms, so I can't take x's from all of them. The most that I can take out is x to the power of 4. Okay, and then finally, let's do the y's. Here I have y squared, here I have y squared, here I have y to the power of 3. The most that I can take out of all three terms is y to the power of 2, because they don't all have y to the, I mean, they all have y to the power of 2, but they don't all have y to the power of 3. So finally, we just have to fill in the blanks on the inside. So now I'm going to put my parentheses. There are going to be 3 terms on the inside. So go back in the same way that we did the other problems. We got to do it again. So -4 times what number would give you -4? That would be a 1. I can write the 1 or I can leave it out. It's up to you. Doesn't matter. X to the power of 4 times what will give me x to the power of 5? Here I can tell that I'm missing an x, because to get x to the power of 5. Y to the power of 2, I'm good on that because I already have y to the power of 2 on the outside. So next term, plus, actually that was a mistake. So since we took out a negative outside, be careful with your signs. Let me look for the eraser now. So since we took out a negative, be careful with your signs, because 4 times 2 is equal to 8, right? For that. But we want to put the negative in front of the 2, because a negative times a negative has to equal a positive, because our original expression was positive 8. So be careful when you do take out a negative. Yes, you do have to take it out. But when you do take it out, be careful with your signs, because they have to match up to the original problem. Okay, next thing. So x to the power of 4, I already have x to the power of 4 there. So I'm good. Y to the power of 2, I already have y to the power of 2 there. So I'm good. Finally, I'm going to do another term, which is a 20. 4 times what will give me 20? That will be a 5, right? And then notice here that I have a -20. So -4 times +5 will give me a -20. Now we just have to account for the variables. So I already have x to the power of 4 on the outside. I need x to the power of 4, so I'm good. Here I need 3 y's, but I only have 2, so I'm missing one more y right there next to the 5. Whoop, I made a mistake. Let me erase that so it doesn't look ugly. So finally, my final answer will be this. So the greatest common factor is -4 x to the power of 4 y squared. And the final answer is -4 x to the power of 4 y squared multiplied by x minus 2 plus 5y is equal to the original problem, the original expression. I hope this video was helpful. Good luck on your assignments. And if you have any further questions, let me know. Thank you.